Future energy revolution. Is nuclear fusion power possible? Hello everyone. Have you ever heard the term artificial sun? Just like the sun we meet every morning, it's the dream technology that creates infinite and clean energy here on Earth. This is the story of nuclear fusion power. Nuclear fusion, hailed as humanity's long-held dream and the future energy revolution. Can it truly become a reality? 1. Bringing the principle of the sun to Earth. What is nuclear fusion? Nuclear fusion is, literally, the phenomenon of atomic nuclei fusing together. It's exactly how the sun produces light and heat. In the sun's core, hydrogen nuclei collide under immense heat and pressure, transforming into helium nuclei, and the mass lost in this process is released as an enormous amount of energy. This is nuclear fusion energy. What makes nuclear fusion so remarkable is that it's the exact opposite principle of nuclear fission, which we currently use for nuclear power. Fission obtains energy by splitting heavy atomic nuclei, while fusion obtains energy by combining light atomic nuclei. This difference creates tremendous advantages. 2. Why is it called the dream energy? The appeal of nuclear fusion power. There's a reason why nuclear fusion power is called the dream energy. It boasts many truly attractive advantages. Infinite fuel. The main fuels for nuclear fusion power are deuterium, which can be easily obtained from seawater, and tritium, obtained from lithium. Since 1 liter of seawater can provide enough deuterium to produce energy equivalent to 300 liters of oil, we can say fuel concerns are almost non-existent, right? 0 carbon emissions. Nuclear fusion power emits absolutely no carbon gases. It's a truly important eco-friendly energy source in this era of climate change. Safe and clean. Nuclear fusion reactions are unstable, so if even a slight problem occurs, they immediately stop. This means there's almost no risk of explosion. Furthermore, unlike nuclear fission power, it does not produce high-level radioactive waste. While low and intermediate level waste does occur, it's much easier to manage. High capacity, high efficiency. Even a small amount of fuel can produce an enormous amount of energy, enabling high-capacity power generation that can stably supply electricity to large cities. Because of these advantages, nuclear fusion technology is attracting global attention as a crucial solution for addressing the climate crisis and enhancing energy security. 3. The process of turning dreams into reality. Hurdles to overcome. With all these benefits, why isn't nuclear fusion power commercialized yet? It's because there are many hurdles to overcome. Maintaining ultra-high temperature plasma. To initiate a nuclear fusion reaction, a state of ultra-high temperature, over 100 million degrees Celsius, similar to the sun's core, must be created. The biggest challenge is how to stably confine and maintain this ultra-high temperature plasma. Currently, the tokamak device is used to confine plasma with a powerful magnetic field. Energy efficiency. For commercial viability, the energy obtained from the nuclear fusion reaction must be greater than the energy required to initiate and maintain it, right? Research is currently underway to achieve this goal of net energy gain. Technical difficulties. There are still many technical challenges to solve, such as developing materials that can withstand ultra-high temperature plasma and ensuring the durability of the devices. 4. Humanity's challenge towards an artificial sun. Ongoing progress. Despite these difficulties, the entire world is making tremendous efforts to make nuclear fusion power a reality. International Thermonuclear Experimental Reactor ITER, being constructed in France by 7 countries including Korea, the United States, the European Union, Japan, China, Russia, and India, is a key project for the commercialization of nuclear fusion power. It's an international collaboration to create a gigantic, artificial sun. Korea's KSTAR, Korea's KSTAR, is known as the Korean Artificial Sun, and showcases world-class plasma confinement technology. The fundamental technologies obtained from KSTAR will make a significant contribution to the construction of future nuclear fusion power plants. Thanks to these efforts, the nuclear fusion technology market was valued at $312.1 billion United States dollars in 2023 and is projected to grow to $543.5 billion United States dollars by 2033. 5. When can we expect nuclear fusion power? Many experts predict the commercialization of nuclear fusion power to be around the 2050s. They anticipate that after demonstration reactors producing actual electricity in the mid-2030s, commercial power plants will begin operation thereafter. While there's still a long way to go, Nuclear fusion is no longer just a dream but a technology nearing the threshold of realization. Conclusion. How about that? Isn't nuclear fusion power truly fascinating? I believe that humanity will successfully overcome this enormous challenge. And one day, nuclear fusion energy will illuminate all our lives. When that time comes, we'll be able to live on a clean earth without worrying about energy, right?